All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanagh here, and I'm so excited to have my buddy Mark Madsen on the line, Third Nature, back from a couple trips. Ran into him in San Diego at the TDWI conference where we met 20 years ago. Time flies when you're having fun. And we also have Denise Muyco with us of Ravel. And we're going to unravel how all these amazing AI technologies get built these days, what they actually do, and what all the workload management is about in the background. Because as you can imagine, there's a lot of processing done. There's a lot of work that's done to get into those GPUs, to adjust the weights and balances and all these parameters. And that's how it actually gets done. So we're going to talk about AI factories. That's the super cool thing that NVIDIA is talking about. And lots of other companies are talking about their AI factories. It's like, ooh, what's that? Is there an actual factory and the machines? I'm like, well, yeah, it's called a data center. And they're ingesting data, but we're talking massive amounts of data. So if you have some model with billions of parameters, I did a show, gosh, maybe 8 or 9 months ago with the folks from Hammerspace, and they were talking about how, with their tier zero storage and their whole interesting approach here, they've been able to cut the hops data takes from 10 down to 4 to get from where it's stored into the GPU. Well, that's a lot of hops. And what David Flynn, their CEO, talks about is that really a lot of the energy consumption occurs in the CPU units on the storage nodes. So they're
Mhm.
also pushing something else very interesting right now called the Open Flash platform, where they're trying to get the manufacturers to basically realize, hey, we can connect NVMe direct to all of these GPUs, and you can basically expedite the whole process and also lower the cost and lower the consumption of energy and all this fun stuff. So this is some of my background, but the person who really knows about that is Denise Muyco. So Denise, welcome to DM Radio. Tell us a bit about yourself and
There.
tell us what do you think about this AI factory thing that they're talking about?
Yeah, well, thank you, Eric, for having me. It's great to meet you too, Mark. Just a little quick background about me. I'm kind of what I guess you would call what they now call a hard engineer. So I have a mechanical engineering background in thermodynamics, and got into, I would say that on the business side, in a very kind of interesting, circuitous way, but. Got into media entertainment and doing HPC processing for films, for visual effects, um, advertising, gaming. So I got into that. So I know I've been in and around HPC for a very long time, for almost 20 years, um, dealing with very, very complex workflows and very, very heavy workloads. So we kind of got pulled into on with Ravel, we got pulled into the AI world about 5 years ago. And what we do today is we call it helping to modernize and optimize both data centers and HPC and AI environments. Means a lot of different things, but we help do that through our orchestration and automation software that we call Ravel Orchestrate and Orchestrate AI. So that's just kind of where we come from. But to answer your question about what is an AI factory? It means a lot of different things to a lot of different people. So you'll see, like with the OEMs that you see, like your Dells and your Supermicros and your HPs, what they call an AI factory is basically infrastructure that is optimized. Think of it like a cluster of infrastructure, primarily with some GPUs and some, side saddle CPUs, in either a rack or in some sort of kind of container like a chassis. And it's basically getting ready to be deployed, with some kind of software sitting on top of it.
Hmm.
And that software is generally going to be your AI engines and your models. So that is what I think a certain group calls an AI factory. Other people call an AI factory. Um, that's actually a data center, as you just had mentioned. So a data center that has a bunch of these high performance compute specific for AI. And that's one of the big challenges that are happening right now, which is taking some existing data centers and converting them into AI factories. So
Hmm.
that is the definition of what I know.
Okay, no, that's a good definition. And I do want to get into the weeds a little bit here to kind of explain to people why this all matters. And I think when you and I were talking earlier, I mentioned how I had a whole past life in the pre-press industry and then some friends who did video effects way back in the 1990s. So, it's like a long, like 3,000 years ago in ancient history. And when you render these really complex visuals, it takes a long time.
Yeah,
And back in the day, you would scale up, right? You would have a big fat machine with lots of RAM and processors and all
yeah,
this stuff. And then, of course, we got to scale out. That was the whole cloud world with Hadoop. And they talked all about commodity hardware, which at
yeah,
the time I thought to myself, there's something sketchy about what you're telling me. And I think when you get down to brass tacks, you really have to get the configuration right and understand
yes,
these machines. And
yeah,
in fact, my data scientist who worked on it with me, a guy named Dr. Jeffrey Malofsky, what he found was, yeah, guess what? The better machines work better. Period. They just
yeah,
work better.
yeah,
And you just run into all kind of problems because that's the real problem with this high performance computing
yeah,
is you throw these massive workloads, you really better know what you're doing because they
yeah,
will just choke the daylights out of your system. The choke could
yeah,
happen anywhere. It could happen in the
yeah,
network, it could happen on the processor and the application and all kind of
yeah.
stuff, right? And that's where you guys come into play in helping to democratize and take an agnostic approach to the environment, right? You want to talk about that?
Yes, yes. I think to your point, it's really about understanding what is the workload. And to understand the workload is what is the size of the origin files that you're looking to process. And then you get into, well, what are the both the AI engines and the AI models that you are using, because that will tell you. Obviously, something that is inferencing like an LLM is very different than generative AI. And you're talking about multiple, you can say like all, the fun words you like to say is like the multiple vectors and all that fun stuff. It's very, very complex. And when you're talking about generative AI, it's just more. And then you have to, of course, then deal with other parameters within that, within just the processing. And that is, again, matching what is the right size for that workload based on that data. What is the in the C in a data center, and if you have different types and different types of configurations, it's basically matching up the best the best configuration for what that workload is, right? And so then you can go into the next layer, which is, okay, well, if I want to optimize my machine, the machines that I have available to me, well, what does that look like in terms of the workload? And then I want to get to the next level as well. Okay, so I've got these machines, and I'm looking at things like power utilization, right? That's another factor. And so you can chase electrons, you can chase time, you can chase dollars, right? And those are all of the factors. Those are some of the major factors that we are helping solve with what existing data centers have today with their power consumption, right?
Right.
So those are some challenges right now. Is power is a huge issue for existing data centers that want to put in a bunch of GPUs, right? So they have to work
Hmm.
with the utilities, right? And those are real practical kind of issues that all data centers, neo clouds, et cetera, are facing today, which is how can we solve the issue, with power.
Right. Well, and I'll throw one more over at you, and then we'll get Mark's opinion on this. We also talked the other day about virtualization and VMware, and I'm old enough to remember when VMware came along, and it was like, hey, wait a minute, we can help you optimize the use of your machinery because CPU usage would be very low and before we had VMware, and they would sort of spread that workload out. And I think they were the first to really understand that and try to help you optimize
Yeah.
that environment. And then, of course, years later, Kubernetes comes along, and I had a conversation with Alex Gallego from Red Panda a couple months ago, and he made a joke about artificial general intelligence. He said, "Yeah, well, if AGI ever does come around, maybe you can figure out how Kubernetes works," which I thought was pretty darn funny. But anyway,
Yeah.
just real quick, I'll throw that over to you because you're optimizing for the environment. And what's cool is
Yeah.
that, as I recall, with your policy engine, you let
Yes.
people determine, hey, do I
Yeah.
want to optimize for cost or for
Yes.
speed or for energy use or whatever,
Yes.
which is declarative in nature, right?
Yeah. Yes. So there's basically two modes. You can do that in a manual way or an automated way. And so when we say the word automated, if you have multiple data centers, which that seems to be a big issue right now as these larger data centers are turning over their older infrastructure and they're doing a refresh. Um, the challenge is that they have so much power right now in a single data center, and if they have a footprint of, we'll call it, 1 million square feet, I'm just throwing out a number. Basically, a fourth of that is now only can be utilized with GPUs. If they were to have a GPU infrastructure and now taking the place of that refresh, they're only utilizing from a square footage perspective only a fourth of that, of the
Hmm.
fourth of what's going on. So that is a big challenge, which then leads us to, you know, okay, so you need more horsepower, so to speak, with respect to you need more GPUs to do the workloads. And so that is kind of where the value is. We've been called the automatic transmission, in many kind of use cases when you're dealing with these workloads. You have multiple different kinds of workloads in a queuing system, and that queuing system does leverage, as you just explained, our energy, the actual policy that is based on the two or three things, or it could be the 10 things that matters most to you, and basically just distribute those workloads to the appropriate environment, if you will.
Hmm, that's very cool. I'd love to get deep into the weeds here. Mark
Yeah.
Madsen, I'll bring you in from Third Nature. I love this policy approach that they take, saying let's optimize for cost or optimize for power, for efficiency, or whatever it is. That's cool stuff. But you've got history in the HPC world going back a couple decades, right? So, and I was always kind of confounded that I never saw a whole lot of innovation go from the HPC world over to the enterprise data world. I remember I was at a conference in Austin in like, I don't know, 2015 maybe, and there were none of the players from the big data world that I knew. There's no Cloudera, there was no Hortonworks, there was no MapR, like none of those guys around. And I think it's because the universities are their own ecosystem, and this is life sciences, and so it's real heavy duty, millions of facets. It's not, like transactional data for a business. It's a very different storyline. But what are your thoughts about HPC back then versus what you're seeing in the world today?
Yeah. When you talk about vendors like that, vendors have to choose where they're going to make their money.
Hmm.
And in the commercial world, uh, there's a lot more tolerance for slop. There's a lot more the workloads are more, I guess I'd call them mostly forgiving. I mean, certain things have to be important. I mean, the reason all those vendors you just listed are extinct is because they didn't meet the availability and performance requirements that were required for data work. And
Hmm.
we're kind of, back to some different players and IBM and Oracle and, the usual suspects again, unfortunately. Um, and it was being driven by workload. Those engines were only good for about 10 to 15% of what an enterprise needed to do.
Hmm.
And you can take that same rule and go back to the period you were talking about and why HPC tech seemed not to make it into our markets, enterprise markets. And I think that was that. What did we use HPC for? Well, number one, we got mired down in message passing infrastructure as a style of programming, which is really esoteric and not like hacking some Python code or Java code or whatever. It's not something you just toss out to your average guy and just say, "Hey, go vibe code this." Uh, it's also the kinds of things that you ran there were simulations mainly. So you were doing physics simulations, nuclear test simulations when we stopped doing nuclear tests and started just simulating them, weather simulations, different types of things. A lot of them were agent based. So you just had these, cell based. So you just have like a 3D pixel for your weather model, and you just have billions of these things, and you do some calculations on each little cubic inch of or cubic centimeter of air, right? And so the calculations are very small amounts of data, very high compute. That does not look anything like an enterprise.
Hmm.
And so that world always stayed a little bit separate. And then personally, I view it as getting hidebound too, because you progress through statistics and machine learning and things start to intersect where you build models and large volumes of data. And then it gets more towards, hey, look, we've got deep learning. What can you do with it? Well, let's build, word to vec and BERT models and language things. And then along comes, transformers on the one side, of course, different ways of using deep learning on different kinds of models that are not language models, like protein folding or, well, AlphaGo would be its own special hell, but these different types of workloads. And so now you've got things that can be commercially applied. And
Hmm.
at that point, I think it starts to really force this intersection, which leads us back to Denise's work, right? Because we don't have any infrastructure for this in
Hmm.
enterprises, excepting the handful of companies that are either, in the AI space or, for me, more interesting, pharmaceuticals, genomics research, power and energy management, very large data set, data and compute models, which is, I break workloads based on data and compute as my
Mhm.
first cut 2 by 2.
Yep.
High compute, low compute, high data, low data. Where do you fit in this? I can very quickly say this is the kind of infrastructure you'll need. I'd kind of
That's
like to,
interesting.
I jabbered on about the history there, so kind of getting us to where we are, but I'd like Denise's take on that too, because, that's a thing. It's different.
Yeah. Yeah,
Yeah.
let's go to the break here first and then we'll come back because this is a fascinating conversation already. And I think the audience already kind of understands now how complex this can get. And when rubber meets road, you have to be very efficient because when you're burning through, I mean, you think about the amount of money that's been spent training these models,
Yeah.
and it's like, well, what is the end result going to be? And I'm pretty sure that what we're seeing right now is a massive ground game to get as many consumers as possible hooked on this platform or that platform because they plan to make money down the road. And they've invested tremendous amounts of money building this stuff, training them. Now it's time to make money. But we'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio, talking all things AI infrastructure, AI factories, where rubber meets road. Where does the data go into the GPU and come out the other end and do cool stuff? It's a pretty long road. And we heard some really interesting commentary from Mark Madsen about workload orchestration and what kind of workload do you have? And the business world is not like the HPC world. HPC means high performance computing, for those who don't know. It's out of the universities, and again, it's for really challenging, very, very complex problems like weather predictions, for example. Lots of data, lots of little nuggets go into doing all that. But Denise, I'll throw it over to you just to comment on that and what you think about how we've kind of had this forced intersection now, in part because of the large language models.
Yeah. Um, Mark's absolutely right, with the way that, the structure of it's the structure of the data meets what's the compute requirement, right? So those two are the two main kind of intersections of, well, what is that's the description of a workload. Where have gotten really involved in HPC, when I say back in the day, it sounds, like back in, like, as you say, in the early 2000s, or in the, in the 1900s. It was all, I was in the media and entertainment business and really kind of focusing on HPC for visual effects, when visual effects was getting very hot. So you have your Lucas and your Lucasfilm and ILMs and your Pixars, and they were the ones that were always pressing the envelope. And I always like to say that's kind of where I really, cut my teeth there when it comes to HPC, primarily because they're doing always the most fascinating things in terms of like really pushing the parameters and the, of how to like manage compute. And you should see all sorts of interesting contortions of with blades, like with compute blades with no chassis. It was fascinating with an ice block and with the fan blowing. It was fascinating in terms of like that's kind of the way that people would cool the chips at the time, because there was not enough to, we were overclocking all of those machines, right, to kind of get the HPC result of a visual effect. So I've been doing that for a very, very long time in terms of the I would say the last 20, 30, 20, 25 years, but it's really where things started to take shape, where more, I would say, commercial application was about 5 years ago. And I'm sure, people called it, machine learning. I mean, I would say the visual effects industry has been doing this for a very, very long time.
Hmm.
And even doing a little bit of inferencing. That we didn't call it that though. So, because the rise of these models, because of ChatGPT, this whole like world has really kind of accelerated its need to understand. And I think the understanding is coming. I would say there's only a few people that really understand, AI and what it, not just how to create a model, but how to train one and how to use it. There's lots of like subsequent like businesses that are spinning out because of it. But where we are finding most of our use cases, when we talk about enterprises using this, it's primarily in the LLM world. And that's, things like if people are wanting to use chatbots for some industry specific things. So if it's like something like with medical or medical records, that's slightly different than understanding the consumption of, a visual medical record, for example. But that's a good use case. So the medical industry, Mark was talking about what's going on with possibly like genomics. That's a whole nother level that's happening. But they've been doing that for a very long time. Like that's been going for a long time. It's just more, faster, you know, and seemingly better. But when we get into other types of use cases, for businesses, it's things like, very simple things like doing a search or looking up, for like the legal world and what they're doing, as it relates to either not just finding documents, but kind of creating documents, pulling things together, making that happen very, very quickly. There's so many different applications of AI, and most of the businesses today, most Fortune 1000 companies are absolutely have made a commitment, a financial commitment. And part of the challenge that we're seeing right now is that a lot of people bought the AI infrastructure, and there's this gap that is, really prevalent, which is like, okay, we bought all this fancy infrastructure, we're ready to go, let's figure out what to do. And it stops, right? It stops because well, what are all the things I have to have in order to put a model on that infrastructure? What does that look like? And so it's that ability to provision all those like little small DevOps things that are required, with the scripting and the Python this and that, right? It's very, very, I would say, detail oriented and, I would say cantankerous for for lots of it, right? It's complex. It's like unwinding like a necklace that's all balled up. So the whole point, and one of the things that we try to do is make it easy, the easy button for all of that kind of in between GUWare, between something that is bare metal, like just infrastructure, through to the actual application itself, meaning the AI engine, and being able to just direct yourself to, well, where's the origin files coming from? Okay, where do you want the output files to go to? So something very, very simple that helps people negotiate the path that's required to get into AI. That is kind of where there's lots of challenges right now, and where we see
Hmm.
ourselves, helping, enterprises, data centers. That's where we see where we are most valuable.
Yeah, that's very interesting stuff. And I'm reminded of one of the things to bring in David Flanagan from Hammerspace. One of the things that he told me last year we were talking about training models and how long it takes. And he joked, he said, look, the GPUs we have today, you could absorb all the text in the world in one day
Yeah.
into these GPUs. But videos are a much different story. And that's when you're talking about origin files, right? That's
Yes.
what you mean is that you have these
Yes.
big honking files where the file essence is
Yeah.
so large and there are so many bits and bytes in that file essence. So how do you absorb that? It reminds me of my grandfather's joke, and I'll throw this to you, Denise, and then Mark, and you can comment on it. He always jokes, "How do you eat an elephant? One bite at a time," right?
Yeah.
It's like, but you
Exactly.
parallelize. I mean, that's really
Yeah.
what you're trying to do is you're trying to parallelize. And what Ravel does is it helps you sort of dynamically orchestrate for the environment that you have. So depending
Yes.
upon how much memory you have, how fast the processors are, how many cores they have, what version it is, of
Yeah.
different pieces of hardware,
Yeah.
all that really matters if you're
Yeah.
trying to make it all hum, right, Denise?
Exactly, exactly. I think one of the big things that people forget about is that VRAM. So I've been on so many calls, with enterprises and with other data centers, and they are buying, millions and millions of dollars of GPUs and CPUs. But the one thing that they have that they forget is they're like, oh yeah, we'll get you, we'll get this X amount of VRAM, but they don't answer the question, which is, well, what is the workload? What are you trying to do? Right? Because you were talking about earlier about NVMe and what Hammerspace is doing to kind of basically take some of that that process data and move it quickly into storage, right?
Hmm.
That is the right answer, I think, in many ways. That is a right answer, I should say. But that is always kind of the challenge that when you're in these enterprises, what I end up doing is doing a lot of like consulting by asking the questions. Well, again, what is the workload you're trying to do? If you want to do multiple types of workloads, you want to do everything from something that's generative AI, which is intensive and it requires a lot of RAM, VRAM in there, and requires, absolutely NVMe would be fantastic, but not everyone can use that or afford that. So then you start to kind of cut corners and what is the experience, and you want to overclock things. Do you want to do that? Are you using liquid cooling? If you're using liquid cooling, maybe you can overclock it. There's all of these kind of
Hmm.
very interesting facets that come into making a decision, again, based on what current infrastructure you have, and then inevitably people want to buy new infrastructure. And so what does that look like, right?
Right.
And so everyone's trying to save power. I go back to power because that seems to be one of the biggest, you know, uh, I would say mandates, at least here in not just in the United States, but also in all of the European countries, everywhere, which is how do you conserve power in the world of AI when there's so much more consumption going on with power, and where everyone's turning to is really on the cooling side.
Hmm.
And so how do you cool the chips? How do you preserve power for those GPUs and CPUs? How do you do that? And that is kind of where everyone's looking more towards direct to chip cooling, evaporative cooling, immersion cooling, which is my favorite because it's
Right. They're
it's like
underwater.
these it's
Right.
like literally in this coolant and these chassis, things that you never would think, oh my gosh, I can't imagine
Right.
this type of electronics into this liquid. It's like it's fascinating, right? And so they're saving power by doing this, immersion liquid cooling,
Hmm.
and trying to save that power. So now you can deploy those, those really heavy workloads or those persistent workloads to something that is immersion cooled, and now you're kind of helping get that the requirements, saving the requirements, if you will, for something else, whatever the something else is. Maybe it's
Hmm.
another rack.
Yeah. Mark, any thoughts?
I think it's funny to bring up power and immersion cooling and things like that because I think back to working in a data center, and it was an HPC data center working on convex supercomputers back in the early 90s. And, we had a bunch of water cooling in there. And you know how dangerous and risky water cooling is around high voltage equipment.
Oh, yeah.
And, raised floors exist for a reason so that when it floods, you don't kill yourself and things like
Yeah.
that. And now we're back again, except that now we're doing it at, gigantic scale. And of course, we're putting all the data centers close to places where there is, say, power generation and sucking up all the groundwater. And
Yeah.
so, like, I live in Oregon and we've got data centers on the Columbia River, which, okay, there's lots of water. And then they've got them in Eastern Oregon, which is a desert. And they're sucking up the water table to cool these damn Facebook data
Yeah.
centers, for example. And, it's amazing short-sightedness and consumption of things. And, it goes back to so many optimization points.
Yeah.
And the point about which hardware are you buying? And that decision has to be driven by what you're trying to do. And yet everybody's out there buying servers. Hey, look, here's the pre-configured Dell NVIDIA combination server for X. But they don't really say, for X. They just say for AI, which could be 15 different kinds of workloads.
Yeah.
Right.
And
Yeah.
and so, like she's saying there, you're buying the wrong gear, then trying to force a workload onto the gear. It's like, my example has always been I bought a VW bus because I need to get pigs to the farmer's market. You know, maybe that's not what you needed. And maybe you should think about what you want to do before you buy the damn stuff. But
Right.
Yeah.
I think well, commercially in enterprises, it's usually show that we're doing something rather than show an outcome, which drives behaviors. And that we don't have a fix for. We can't optimize for that. You can't optimize for bad management.
Well,
Um,
you never know. They might be
yeah,
able to soon, man. I mean, I
yeah,
think
right.
about what.
AGI can't come fast enough. But where I was going with that is just that you like Denise is saying, it's workloads, but there is the workload, which is the thing you want to do, that task. And then there's a piece of that which is, well, how do you want to do that? I could use conventional statistics. I could use agent-based simulation. I could use some deep learning model, each of which has a different compute and storage footprint and
Yeah.
or consumption, I should say, footprint.
Yeah.
And we leave networking out, but that's probably the biggest problem. And then from there, you take that to at what scale, is it this big or that big, which goes down to, how big is your company? Because most companies, it turns out, don't have enough data to do things like, visual detection and prediction from MRIs or X-rays or something, because no individual hospital has it. You need a collection of that data in order to actually do the kind of training that you do, which is why we end up falling back to other sorts of
Hmm.
techniques. And now you've overbought a set of hardware to do something you can't do and have to revert to different kinds of image processing,
Right.
so it all starts there.
Well, and this really speaks to the importance of talking to the experts, understanding what you're trying to do, being very methodical about what you're going to try to achieve. And as my old boss back when I met Peter Quinn, but when I met Mark, used to say, "Let's achieve what we're trying to achieve." I always loved
Yeah.
that. I'm like, "Damn, that's good." Well, folks, don't touch that. I'll be right back. You're listening to DM Radio. All right, folks, back on DM Radio. Fascinating conversation with Denise Muyco of Ravel and Mark Madsen of Third Nature. And Denise, Mark was just saying there are all these different problems you can have in different places. You've talked about this too. And I remember in the Hadoop craze, and Mark and I were two of the people kind of going, "Are you guys sure about this?" Back when that all went down. The network, when a node goes down and has to be repopulated, the network would just go bananas, and that's just one thing that can go wrong, right? But what do you think, Denise?
Yeah, it's interesting now. I mean, the networking is getting pretty sophisticated. So, one of the things that is important, even I shouldn't say even, um, you know, I would say solutions like VMware, and I'd say there's more modern technologies out there too that kind of detect whether or not a GPU is down or a CPU is down. It doesn't mess up the network as much as it used to, but it does provide an alert. And so if there's extra capacity, this is kind of where, again, we would come into play here. If there's extra capacity, and this is kind of what's happening with lots of these, I would say these installations that we're doing, we see that there's always an extra rack of infrastructure that's there, almost like a DR kind of situation, like a DR or high availability HA kind of situation where you can basically go to the next node over, if you will, into that extra the extra bucket of GPUs that's on standby. So we're seeing that's now a common use case. So that network is not necessarily going to go crazy. It's just going to go to the next. So our technology will say, that's down. As long as it's in the policy, it understands in the policy, it'll go to the next available machine, provided that it's part of that network. So that's how that problem's now being solved. I mean, there's other technologies, like I said, out there that do detection. But I don't know if they do that N+1. I haven't seen that, which is like, this is down, go to the next. I'm
Mhm.
sure they have that feature, but that's more usually from a manual perspective. The operator who's operating that, they'll get the detection and then they'll kind of make an adjustment and they'll manually do that. So our technology allows that manual intervention, but it also can be put on autopilot, if you will, and go to that N+1, that next node that is needed to achieve your 1,000 nodes that are running at the same time, or your 1,000 GPUs that are running at the same time.
Right.
Yeah, that made me think of something that you just said right there, which is, the size of the workload. And of course, you can optimize your farm. You can have 1,000 nodes do it
Yeah,
more quickly, or 100 nodes take
yeah,
longer. And,
yeah,
that can be obviously arbitraged. But typically in an HPC, like foundation model training or some sort of big deep learning training cycle, you prep a cluster. You know,
hmm
you, well, if you're doing the hardcore like weather sim stuff, you would actually configure the hardware, figure out your virtual machine, figure out how you're allocating things within the VM, populate the images, then, shunt it all out there. And so there's multiple wads of stuff that have to move across networks and storage networks as well and get populated. But then when you're running, part of that arbitrage that's really hard from a manageability and operation standpoint is you have 1,000 nodes and you're doing a particular type of workload like training, and you lose one node. What's the recovery look like for the one node? Because if you were doing some big global synchronization based on a bunch of distributed computation and that node went down, you can't finish the synchronization until that node's work is done.
yeah,
And, a lot of that style of workflow plus orchestration of the work being done as it's being operated um, is something that I think Denise alluded to earlier, where people are hacking together Python and doing this and doing that. Meanwhile, over in like Los Alamos, where we've been doing nuke sims for decades, that stuff's been built to a custom data center cluster, because back in the day, up to even today, the supercomputer is the cluster and the cluster is the supercomputer. The real sea change I see in the industry is that you now have the ability to distribute configurations, to reconfigure more on the fly than you used to ship machine images out and do things where you can carve up a cluster instead of having to set up one 3,000 node cluster. And that means that you can do things you couldn't do before, where like is still true today. Foundation modeling takes, say, well, about 3 weeks or more of 24 by 7 continual operation. And that is super high av. And, we're not talking disaster recovery, just keep the thing running. Because if you break your cluster halfway through, you just lost a week and a half of a massive amount of people's time.
yeah.
Now, most orgs aren't working at that scale. So I feel like that whole piece of what does the workflow look like for the workload that you are doing? And I'd kind
hmm
of like to hear Denise talk about VFX, visual
Yeah,
effects, big file media
yeah,
processing versus small
yeah,
snippet foundation model training, which are
yeah.
two very different things in how that optimization works.
Yeah, in the VFX world, what usually happens, and to your point, because we've worked with those like big national labs, right? We do work with them too. Um, and what usually ends up happening, it's not as simple as just as I was saying, but you made it more clear, which is it's about the physical machine image. It's about everything from the infrastructure to what's the OS to then what is what I'll call like the middleware in there, which is like what are the software images that go on top of that, like that, all of that. You're right, has absolutely become a lot easier now to basically lift and shift that very quickly. So if there is a node that's down, right, this is what happened in the visual effects industry. Basically everything is arrested because there are sequencing that has to happen, right? So the sequencing is extremely important in visual effects too. You can't there are some, if you're doing like layering, if you're doing like a visual effect, there are different layers, but when you're pulling something all together, everything has to go in a sequence. And that's the same for that you're referring to in these sims. But it's really about like our arresting the actual job itself, that I would call it that processing job itself, and either waiting until that n+1 is found, loading up all the things that it was supposed to be doing, and then the whole thing starts again. That's kind of how the visual effects world works. It's very similar to how any kind of even if it is inferencing or if it is generative AI, if it has the end result that you're looking for, that requires the pulling together of all of that data, and it has to be sequenced. That is how we do. We actually arrest the actual job itself until the machines
Hmm.
are properly loaded. That's how that works.
Hmm. Wow. That's that's pretty cool stuff. And we got about 2 minutes left in this segment, and then 8 more minutes in the podcast bonus segment. So just real quick, Denise, I'll throw it back to you.
Yeah,
You're sitting on top of these environments, and you're monitoring what's happening, and you're doing some sort of assessment about what the workload looks like, and that's why you're able to optimize. I mean, I think there are
yeah,
lots of different ways in different parts of the stack where this kind of thing gets done. Software defined networking, software
yes,
defined storage.
yeah,
This is basically software defined workflow automation, if you get right down to
yeah,
it, right?
yeah. Exactly. It's really, again, it goes back to what is the environment, what is the workload, what do we have to work with, right? And that's again from, if you're talking about like what's the algorithm or what's really the IP, it's pulling all those things together and basically saying this is going to work, or we give the warning, hey, this may not work. You're trying to do a GPU load on a bunch of CPUs. Are you sure you want to do this, right? Because there's certain things that you can do some, I wouldn't say all workloads on CPUs, but I will say that a lot of people in specific industries choose CPUs, and we can talk about, the ARM 64. We can talk about these kind of like more, I would say, quicker to process CPUs, which is the ARM technology. Or we go back to like the big GPU, right? So
Right,
the question is, you know, um, which one, depending on who the end customer is, what do they care about? Do they
right,
have a budget? Are they really investing? Everyone needs to do AI. Everyone wants to do AI. So again, it's going back to that consultative mindset of, well, show us what you have in
right.
terms of your infrastructure. Do you intend to buy anything else? What are your workloads, right? What are your data sets? What are the models you want to use? What are the engines you want to use? And then let's have this conversation, right? And
Yep.
so
And
then we can
folks,
say,
and let's pick this
well,
up after the break. We'll be right
yeah,
back. Stand
for
by.
sure.
Let me get a drink real quick.
All right, folks, back here on DM Radio, time for the podcast bonus segment. We were just talking to Denise Muyco right there of Ravel, and you were finishing up a very interesting point. And here's what I heard that I thought was brilliant. And I'll throw this over to
Mhm.
Mark maybe to comment on is
Mhm.
your system will when the person is wanting to about to do the job, your system scans the environment and goes, wait a second, like you may not want to do this. And that in and of itself is a tremendous value because to Mark's point a minute ago, if
Yeah,
you try to do this job and it doesn't go all the way through, I mean, depending upon the job, and this is what I saw in the 1990s. Like these guys would try to get everything, get all the I's dotted, T's crossed, and like, okay, hit the enter button, and then go home for the weekend and hope and pray that you got in there on Monday and the whole job ran. Right. And so having that warning signal in and of itself, that's pretty valuable. What do you think, Mark Madsen?
Yeah, I think that's hugely valuable. I think it's, for a few reasons. One is that a lot of people who are working in this space outside of, deep expertise that have been doing it for a while is still learning their way around what it means to orchestrate these things, how they fail, the failure modes, and what that means. Um, and then you look at the failure modes and you look at the knowledge base. And one of the things that has happened with cloud is that we have de-skilled an entire data center operator workforce. Right? You think about, oh, hey, we're doing agile and DevOps, whoop-de-doo. I worked on giant web farms, with thousands of nodes and had to architect software for those things. And the truth is that most agile DevOpsy workloads are people building features on top of
yeah,
mobile apps or websites,
totally.
and they're deploying on top of the iceberg all the stuff that's sitting below the water. And who maintains all the crap that's under the water? And it turns out that the ops part was still their weak point, and so we had to come up with a new title. So I think it was Google or somebody who said, let's call them site reliability engineers. Right? And so SREs are the
Wow.
DevOps operators
Yeah,
and deal with the infrastructure, the software, how it works and everything. And now we've got these things where, you know, you're trying to do some sort of big, heavy machine learning workload or something, and you've got to orchestrate and manage that. And so you have to understand all the pieces, parts. And you don't do that by like building a car by buying a bunch of off-the-shelf parts and putting them all together. You design it first, or at least the major pieces first down to components, so that I think, to use her analogy, you could grab a transmission that
yeah,
has, a fit for your powertrain. And then your other pieces can be assembled within that frame. And this takes architects and designers, or in this case, I'm talking, people like SREs who understand these subsurface layers. And so the great de-skilling of cloud is actually going to come back to hit you here if you want to do it in your own data center.
Wow.
And so, personally, I tell people a lot of times until you're familiar with what you're actually doing, use some cloud infrastructure, do some basic things. Once you know what you can actually put into production, then go and buy things and think hard about this and find a specialist who knows how to configure servers. Because, she also mentioned about things like VRAM configuration. And, if you're doing very uh, low latency work, which is foundation model fine tuning and foundation model basic training, that is language models. Lots of 2K files, billions of them. They
hmm,
have to be read almost immediately. And so you configure a server by getting a high powered GPU, enough memory in the GPU, tiered memory in your computer, but more importantly, you buy a smart NIC, a network
hmm,
controller. What is that thing? It allows you to bypass the CPU and bypass the system main memory, talking directly over the network, bypassing the operating system kernel to talk to storage
Hmm.
so that you can get ultra low latency fetching. But
hmm,
if you were to try and do that with, a VFX pipeline, that might not be the optimal hardware choice. And so it takes skill and expertise. And I think we very often just assume you can go and buy something. And then you get a bunch of pieces. And, the best of each of these pieces doesn't make a car. it makes a pile of pieces that are not doing what a car is supposed to do.
Yeah,
That's
that
an
is so true. I cannot tell you how many times I go into meetings and they're asking me what their configuration should be. That's like billions of dollars, and they're putting that in the hands of someone who's doing software, right? So I find that hilarious. Like I don't want to be responsible for that, but like I can tell you this is what, I could run a workload carousel if you'd like, and can tell you kind of like how things are working. So we have that kind of functionality. We built that so people can say, yeah, I'm going to use this kind of um I'm going to use this kind of model, and I'm going to use this kind of engine. And so this is what I want to do. Here's some files, like run it. And then they almost have to, it's trial by fire, which is, I think, fascinating because they don't have that expertise or that knowledge. And I don't know if, I think it's two things. One is that they just don't have experience in HPC or AI. Like they don't understand the workloads, right? And it's fairly new. So we do a lot of education. And so I don't know. I think we should go on the road, Mark. What do you think?
That'd be fun.
We gotta go on the road, do a road show, and like do like a lunch and learn training session so everyone kind of understands this, because I think it's gonna make everyone's lives easier. It's going to reduce that financial and technical risk that's kind of hanging in the balance. And again, we're in these meetings. I'm like, oh my gosh, this is a major telco, for example. And I'm like, oh, wow, yeah, like you're going to put an $80 million decision in my hands. I don't want that decision. But you could use our software to kind of figure out what you might want to do, and you can grow from there. How's that? That's a lower
yeah.
risk. That's lower risk for us.
Well, that is very interesting stuff, though. And so this carousel, you call it, and we'll kind of close out on this.
Yeah,
Basically, what you're doing, and I'm so fascinated by observability in general. I think this is really we're in a very interesting point in time, although it's a bit of a paradox in a sense because I credit Kubernetes with the explosion of observability. And the reason is not necessarily the best reason because we got Kubernetes and it works great. Look at all the stuff it does, but look at all this other stuff that it does. And like, what does that
yeah,
mean now? Oh no, like now you're trying to like figure out what's going on in there. I was talking to a guy today from Bit Dev, very interesting company out of Israel. And he's like, yeah, well, the AI is going to create all this code and you're going to need AI to understand all the code that you just created because people won't be able to understand this stuff anymore. I'm like, oh my goodness, like we're creating these problems. But it is fascinating to really get into the weeds and understand what is happening. And there are not many people who know that kind of thing. So, and
yeah,
to Mark's point there, I just got chills thinking about it. Oh, no, we've de-skilled the data center workforce, and now nobody knows this stuff. And it's like, okay, you can chat GPT it, and maybe you'll get close, but you got to get it just right if you're running a data center. Well,
yeah.
folks, look these people up online. Denise Muyco, it's Muyco of Ravel, Ravel, and Mark Madsen of Third Nature. And send me an email if you want to be on the show, info@dmradio.biz. You've been listening to DM Radio.